Hello people, I'm gonna show you how to record fit a car in xmgrace. So here we go. So I made a script which calls in some data files and fit the car with the parameter file and to .car. If you want to know how this works, you can just go back and look to my previous videos to see how this parameter file works. So I'm gonna comment out this line so that only the first xmgrace segment will be called upon. Right. I'll save it and I'm gonna run it. So here we have the car that we are going to fit. Now I'm gonna take in the nonlinear car fitting. So what you have to understand here is that you need to select the sect that you're going to fit, and here is the equation that you're going to fit this car with. Alright, so let's write it up. So you can choose the parameters before. For example, I'm gonna choose 7 parameters. Start from A0, A1, A2, A3, A4 and A5. Well, I'm gonna choose 7 parameters for my equation, and I'm gonna write the equation here. So A0 plus A1 x plus A2 x squared should be in the brackets. Sorry. And you know, it's my particular this equation is ideal for this kind of curves that I'm using. So, but you can really use any kind of functions. Like if you think that can be fitted with a function like a Gaussian, you can do that. It's just a matter of, you know, just you have to tell xmgrace that you have to fit this function, you know. So here we go, A3 plus A4 x plus A5 x squared plus A6 x cubed. If you ask me why I'm using this kind of function, I don't really have an answer, because there are many different kinds of functions that you can, even if you can use the library of the xmgrace to choose the function, but here I will be using a custom function that I use it for my curve here. Alright, so the next step is to give appropriate initial parameters here. Alright, so here you have the tolerance, which means that the fit will this in layman terms it denotes the accuracy of your fit, right? Less the tolerance, more the accurate is the fit. And you can tell xmgrace how much you need to iterate. I usually do 500, which is really fast here. And the next step is to give the initial parameters for the fit. Alright, so here is the value of the initial parameters that you can give. For instance, I'm gonna give it like well, 0.1. I'm gonna put it 0.0. Well, you can do it anyway. So what I'm going to do is to put some bounds so that I'm not out, you know, if you don't put these bounds here, Yeah, well, you can, but if you don't put it generally, this A0 value calculated by xmgrace will go like 10 to the 6, 10 to the 7, 10 to the 8, some crazy numbers which you don't want. You know, like you cannot even write that on a paper like that much zeros. So I'm gonna put it 0 and 10 because I know that this parameters could be between 0 minus 10 and 10. So I'm gonna put it like that, bounce minus 10, 10, minus 10, 10, minus 10, oh, minus 10, ah, plus 10, right? Yeah. And here you go minus 10 and plus 10. Minus 10 and plus 10. Alright. Now, the thing that you need to be careful here is that when you choose the initial parameters, it should be within this bounds. If you set the bounds, you know, if you see this red button here, red square, it means that this the parameters that xmgrace will calculate for you will be between these two bounds. For example, if I try here with a number out of the bound, for example 11, xmgrace is gonna complain that these parameters are out of bound. We can try. So before, select your initial set. Alright, and you don't have to select the final set. If there is no final set selected, xmgrace will create a new set which will be called S1, obviously. Now if I click apply, it's gonna complain that initial values must be within the bounds. So let's say it's 1, give it 1, and I'm gonna click on apply. So this is the first fit that is that xmgrace calculated. It's an ugly fit, to be frank, but don't worry, you go on applying, you go on clicking apply till it finds a good fit. Alright, it's just the first initial the first iteration that it's done, right? It's the second set of initial parameters that you can use. Now xmgrace will use these initial parameters for the next fit. Again, apply, apply, go on doing that. Okay, so we don't have a good fit for this. Okay, it's a fail, but I'm gonna try differently. Yeah, alright. So what I did here is that I randomly changed some initial parameters. Alright, it's good to know which parameters will be affecting the shapes of different, you know, different parts of this curve. But for now, random selection of initial parameters works. Alright, so we have here the final parameters that xmgrace found for the red curve. Red curve is the fit. And here you have the chi-squared, which will give you the goodness of the fit. Correlation coefficient about 1 will be good, near to 1 will be good. Tail U coefficient, I guess TL was a mathematician, and this will give you the amount of randomness, we call it entropy of this curve, right? Lesser TLU, better the curve. Now let's put some symbols here for our initial curve, which is S0. So let's say circle, and so we can see this red curve is actually a good fit, you know, kind of works for me. Now you can, there are some other options here. You can choose the advanced option, and you can put some restriction before you need to define some region. I will explain that in a later video. You can put some weights, for example 1 by y square, by derivative of y square. And also you can type in your custom function, which you can put some weights. So it means that if you need some part of the curve to be fitted exactly as your initial data, you can put some weights and tell xmgrace that that part will have higher weights. Right? It's just a matter of importance of specific regions. Now the red curve is the loaded curve, right? So it says fitted values. Okay, so you can choose the function, right? The fit is always a function, and you can choose where to start and where to end. For example, I'm gonna end at 5, and you can choose the number of points of the fit, right? When you click apply. Okay, so I says error evaluating expression for weights. So I'm gonna change it to none. Alright, so here we have the function that you can see. Now if you look at the set, it turned into 500 points as expected. Alright, that's for today. I'll be back with some more in the future. Thank you.